Hello, my name is Paul Skillin. I'm a graduate research assistant at Oregon State University, and today I'm going to be showing you how to extract cannabinoid compounds for ratio testing using HPLC. The equipment I'm going to use for this include Falcon conical centrifuge tubes with ball bearings, a spec sample prep 1600 mini G tissue homogenizer and cellizer, a Cole-Parmer multi-tube vortexer, Acrodisc syringe filters with hydrophobic polytetrafluoroethane (PTFE) membranes, 0.2 micrometers, plus appropriately sized syringes, Agilent's 1260 Infinity 2 high-performance liquid chromatography system, and Agilent's OpenLab ChemStation software. For the Falcon tubes, I'll be using 50 milliliter size tubes, but this particular size is not a requirement, and will depend on your sample size. Add your plant material and ball bearing, freeze at -80 Celsius. For ratio testing, you can use fresh material that is flash frozen, or you can use dried material which could be frozen at a slower rate. If you're going to determine the plant weight by weight, you would need to have a very dry sample or have determined the percent moisture. But for this demonstration, we're going to be doing ratio testing, which isn't going to require dry material. Either way, you're also going to want a housing for the tubes to go in to be at also -80 Celsius. This will keep the samples frozen while they are pulverized. The housing will also prevent the tubes from shattering during the pulverization process. If plant material is allowed to defrost before the ball bearing is removed, it will become mushy and cling to the ball bearing, causing a loss of material. Load the block into the adjustable clamp. Press down the levers and tighten the locking screw to secure the samples. Pulverize for 1 minute using the spec sample prep 1600 mini G. I'm giving specifics for this particular piece of equipment, which works very well for us, but for each of these steps, there's likely several options that could work very well for your own purposes. To remove the samples, just do this in reverse. Loosen the center locking screw and lift the levers. It's important to verify that the samples are fully broken down. This is what that looks like. Pieces of stem may still be present, but soft tissue should be completely broken up. If this is not the case, as in you are seeing whole pieces of leaves, then they may need to be manually broken down, which will now be demonstrated. Once the sample has been pulverized, it is time to remove the ball bearing. Right after this, add 20 milliliters of methanol. The methanol is going to elute the cannabinoids. Again, it is important to move quickly at this point so that the plant material does not defrost before the ball bearing has been removed and the methanol has been added. The next step is vortexing the tubes. First, put all the tubes into some sort of rack or housing to keep them stable during the vortexing process. Once the housing or rack is loaded, secure it by pressing down on the top and tightening the locking knobs. Vortex at 2500 RPM or 30 minutes using the Cole-Parmer multi-tube vortexer. After 30 minutes, the cannabinoids should be fully extracted. Draw out 2 to 3 milliliters of the resulting solution using a syringe. Attach a 0.2 micrometer PTFE Acrodisc filter and depress the plunger to filter the solution into whatever container that is most appropriate for your HPLC equipment. For the Agilent 1260 Infinity 2, having 2 to 3 milliliters of solution ensures that there is enough material to actually be sampled. The appropriate amount may vary depending on the system that you are using. Your final step is to actually run the HPLC. In our case, we used an Agilent 1260 Infinity 2 system. The output was analyzed using Agilent's OpenLab ChemStation software. This is a fairly complicated piece of technology, and I would recommend using an expert who is already familiar with the hardware instead of using my instructions. The output may need to be manually adjusted, and this is something that is only going to be possible with experience. If you are needing help, Agilent does have some useful tutorials online and on YouTube. Depending on your end goals, it may be necessary to do a second run of your samples using a dilution. Since your equipment is calibrated at particular levels, anything above your calibration curve is going to need to be diluted and then run again to get an accurate reading. Dilution runs aren't always necessary for ratio testing, though. They would be necessary if the detector has been saturated. I hope these steps are helpful, and good luck with your extraction.